Physics is not a big deal when you know exactly how to go about it. Now, when you're studying physics, especially for any competitive exams like JEE or neet, you need to understand what topics you need to study, how you need to study, and how you can actually inculcate them in your brains, in your minds, in such a profound way that you will never forget these topics ever again, even while you're preparing for your exams and beyond that when you actually go into your college. Today, I'll give you some very simple tips, a small overview of how to go about learning physics in your 11th and 12th grade. Let's get going. So, here you can see a mind map that I have made on my screen. I have divided 11th and 12th physics in this manner. First, let's go into the 11th physics parts. I have 5 categories that I've put over here. Your basics, what motion is, properties of solids and liquids, thermodynamics, and kinetic theory of gases. Of course, depending upon what board you're studying from and all of that, some topics can shift from here and there, but to give you an overview of how you can bring your topics together. This is actually the first tip. You need to understand how you can interlink these topics to build up your understanding. We need to master this chapter of units and dimensions. You need to understand what units are used in your SI system. How do you convert between units, significant figures, all of that, because this forms the basis of all of your physical calculations that you'll be doing as you go ahead. So when you talk about motion, I've also divided motion into two, periodic and non-periodic motion. Periodic motion is that kind of motion that keeps on repeating after a certain amount of time. That's a periodic motion. So the most prominent example of periodic motion is your waves and any particular oscillation that you do. Those are examples of periodic motion. When you study periodic motion, you're basically studying how your waves are working. But before you study periodic motion, I would want you to study non-periodic motion. Why? Because that has an entire basis as a baseline for all of your study of your periodic motion as well. So when we are learning any kind of motion, we are learning its kinematics first. I should have put it in that order. You learn the kinematics first, then you learn the dynamics of the motion, and then you learn the applications of the kinematics and dynamics. Let me edit it now itself. Kinematics and dynamics. So you study the kinematics first, then you study the dynamics, and then you study the applications of those both. So when you say kinematics, what are we trying to look into? We're trying to look into what motion is happening. Kinematics tells you what motion is happening, and that can be explained by your laws of motion and equations of motion. Dynamics talks about how this particular motion is happening. So that is where we look into work, power, and energy. What forces are there and how you're providing energy for those forces to act. Forces come under the kinematics and energy comes under the dynamics of your non-periodic motion. Now, applications when we're talking about, I have mentioned 2 topics over here, rotational motion as well as gravitation. Both of them, after all, use kinematics and dynamics, the overarching concepts of those in detail over here as well. Of course, you have a lot of other topics as well, like center of mass, all of those things that come into the picture. That comes as allied topics to all of these main topics that I have mentioned over here. So when you know the kinematics and you know the dynamics and you know how to apply them, now you can use this same principle for your periodic motion as well, for your waves and oscillations as well. How your motion is happening when it's oscillating. What are the energy dynamics with that? That becomes important. So now that you've talked about kinematics, dynamics and all of that in general, we look into material properties. Because of course, when we're talking about physics, we're not just talking about abstract things, and we're not just talking about bodies that are so minuscule that their material does not really impact the physics. That is unfortunately not true. The material, the medium in which these studies are happening are also important. For that, we need to study the properties of solids and liquids. What happens when you stretch a particular solid? What happens if a liquid is too viscous? Laminar flow, continuous flow, all of that topic, all of that concept comes into the picture over here, because that helps you understand how your kinematics and dynamics of emotion within those media or with those particular solids changes. Thermodynamics. What importance does that hold now? The name itself tells you we're talking about the dynamics of another type of motion. We're talking about dynamics in general. But here the main driving force is heat energy. So thermodynamics forms a basis for a lot of our physical processes, and that is why it's important to study thermodynamics in detail. Kinetic theory of gases is mentioned again separately, even though it has quite a lot of linkage with thermodynamics. Kinetic theory of gases basically helps you understand the motion of gases, particular molecules within gases, and how they interact using all of the concepts that I've already learned, including thermodynamics. That was an overview of your grade 11 physics that formed a strong basis of your study throughout your 2 years of 11th and 12th. We've looked into how to report units and dimensions. We've looked at motion, the kinematics and the dynamics behind it. We have looked into your material properties, solids, liquids, and kinetic theory of gases. We have looked into thermodynamics. Grade 12 physics takes care of electrostatics, electrodynamics, optics, modern physics, and electronic devices and communication systems. Now you can see that. Unfortunately, I can't put it in my screen yet. I'll just bring it. Yes, now you can see it all in my screen. Electrostatics talks about how static charges interact with each other in free space. Now this can also have, say, a particular dielectric medium. All of that concept of what interactions are happening are what you're going to be studying in electrostatics. Understand the baseline. Electrostatics this is a study of interactions between static charges, charges that do not move, and their surroundings. Electrodynamics. Now we are dealing with energies again. But here your electric charges are moving. That is why we are studying current electricity first. When you have charges moving along a conductor, it generates a magnetic field. And depending upon how your current is oscillating, you can have electromagnetic inductions that are happening. You can use the magnetic field to produce an electric field, you can use the electric field to produce a magnetic field, and you'll understand how the both of them are interlinked to form something called as electromagnetic waves, which I mentioned over here. Optics deals with reflection as well as refraction, and to some extent even dispersion. So all of your aspects of light are taken into consideration. How light moves around in particular media, how that can be used, are all studied in optics. Modern physics deals with the idea that matter is not just a particle, it can also behave as a wave at the quantum level. That is what we're studying with the dual nature of matter, and how you have its implications coming within atoms and nuclei, how that changes, how your quantum physical model, quantum mechanical model of atoms and molecules are impacting their study. And finally, when we talk about electronic devices and communication systems, we are talking about logic gates. We're talking about a lot of and junctions, all of that stuff comes into electronic devices and communication systems. So this was a basic overview of your JEE Physics or NEET Physics also for that matter. I've just mentioned in general JEE Physics. So I have gone over what are the divisions that I have made within your topic to understand it better. How do you start off with that? The idea is simple. First, when you're given a particular problem, say with physics, you're going to be dealing with a lot of problems. You firstly visualize it. Say, for example, you have been given a problem that you have a ball that has to roll down a slope, and there are particular forces acting on it. You visualize it. You visualize the slope, you visualize the ball rolling down. Then you express it in words. That's something that usually people never do. What is exactly happening in that problem? You don't need to use physical language for it. You don't need to use scientific language for it. Use your words in general to understand your problem. When the ball is say rolling down a slope, the slope has an inclination of 45 degrees. It is angled at 45 degrees and it is a smooth slope. What do you mean by a smooth slope? It may not experience friction. These are some simple words that I've used. Some might feel that it's scientific, some might just feel it is intuitive. Just do it for your understanding. And now you can explain the problem using laws that you know. Physical laws are unbreakable, at least on this planet that we're living. And as far as H.C. Verma goes, there's only one problem that I've ever experienced where it's talking about something outside of the earth. So you can explain problems using laws that are applicable on the earth, physical laws that are unbreakable. So now let's stick to the example of the ball and the slope itself. The ball will roll down the slope. Why so? Your inverse square law of gravitation. But how does it actually work into it? Now you are going to use vectors to figure out what component of the force is acting. You're going to see there are some other forces that come into the picture. You see how those forces cancel out using, and you'll be able to calculate the momentum using Newton's second law of motion. Now knowing that you have these laws acting, start expressing them in equations. Now you can interconnect that the gravitational force component along the slope is responsible for the motion. The gravitational component normal to the slope will have a reaction force experienced by it because of the slope, and that cancels out. Since it's a smooth slope, there is no friction acting, so the only driving force is the gravitational force component along the slope. And now that you've solved the equation, you'll be given all of the mass, you'll be given the, of course, every constant, everything, and you calculate. That's how you solve. This is how you do physics. This is how you understand physics. This is how you learn physics. Visualize, express, explain, and solve. That's all you need to do. This was a small overview of how your physics is going to be dealt with. And these 5 simple tips that you start off with will give you a strong edge towards being able to score it absolutely amazingly in your exams. With this, I sign off for today. Thank you and happy learning.